Are you looking for a reliable machine shop? Or maybe you need to find a metrology lab, or perhaps a service provider for scanning and reverse engineering. If you need to find vendors for your engineering or manufacturing project, visit vendors.teampipeline.us. It's free and helps you and your team find great vendors to help you succeed on your projects. You can also share a few of your favorite vendors with the community. That's vendors.teampipeline.us. Check it out today.
Once you get to the point where you do have to hire a manufacturer for whatever reason, because of the technology or the volume or whatever else, understand that manufacturers are very, very good at what they do and rely on them for their expertise.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we're speaking with Chris Denney. Chris has a degree in electronics engineering and is CTO at Worthington Assembly Inc, where they specialize in small volume prototype and production runs of highly complex printed circuit boards, or PCBs. Chris is also co-host at the Pick Place podcast, where they discuss the PCB assembly process and design tips that will make your manufacturer love you. Chris, welcome to the show.
Thanks so much for having me, Aaron. Yeah, that's a good point. Make your manufacturer love you. That's what everybody wants, isn't it?
Yes, it is. That's always a good sign for sure. So, Chris, what made you decide to become an engineer?
You know, I've been planning on my response to this ever since I started listening to your podcast, because I'm thinking, I don't know. And I think that's a response a lot of people have, right? When I was in high school, I just needed the gas money, right? And I worked at this contract manufacturer, and I met some of the engineers there and thought what they were doing was pretty cool, and decided to get a degree in it and stick with that. But I mean, like most people, like you've interviewed, you know, we all play with Legos and Connects when we were a kid, and you know, and that carried on even like in video games. Like I loved like SimCity and Roller Coaster Tycoon. Like all my buddies are playing Half-Life and Halo, and I'm like trying to build the coolest roller coaster, you know. I don't know. It's in the blood, I suppose.
Yeah, I was always into Tetris. That was my video game.
Oh, yeah. Oh, of course, yeah. I never had the reflexes for that, you know. I just couldn't, like, I'd get to level like 8 and I just couldn't. Just not fast
see, that's
enough.
Why you went into electrical engineering and I went into mechanical.
There you go. Yeah. I suppose that's it.
All right. Well, how did you get started as CTO at Worthington Assembly?
Well, I went to work for a startup after graduating from college, but they made equipment for electronics manufacturing. That's what they did. And got to visit like all these super cool factories all around the country, Mexico, Canada. Really just it blew my mind as a young person, and not having really been exposed to any other manufacturing besides this one company I worked at through high school and college. And then I went, shortly after that, I got recruited by a sales rep firm that, I don't know if your listeners are familiar with independent manufacturers reps, but they get their business models, they get commissioned by selling machines. And so they hired me to help sell machines. And it turns out I'm a much better engineer than I am a salesperson. So the folks at Worthington Assembly were looking for somebody to help them grow their business. They were very, very small at the time. So it's not like we're significantly larger now, but I think there are about 10 people at the time. And had got bought by new management and were interested in working with me. And 11 years later, here we are, still doing it.
Wow. What do you think it was about the way you presented yourself or your background or experience where the leadership at Worthington said, yep, you would be perfect here?
So the owners were, you know, they're not manufacturing people themselves in the sense of like they're not engineers, they're not running machines. That's not it. You know, they're perfectly capable of doing it. It's just not what they're interested in doing. They're interested in running a business and hiring the right people to take care of all the other stuff that they don't want to have to worry about, right? That's business 101, I suppose. And just, I don't know, you know, we're all young, we're close to the same age, enthusiastic, I'm passionate about the industry. I really enjoy it. I really like it. I like all the aspects of it. That can come through in conversations, and we just hit it off, you know. And also, because of all the traveling I had been doing and all the factories I had been visiting, I was chomping at the bit to implement these things I had seen and to steal ruthlessly, so to speak, right? And take all these great ideas and implement them somewhere and see if I could do it too. And it was a really exciting opportunity, and everybody just wanted to make it successful. And you know, it's just being a small company, being a 10-person company, it was also like a great opportunity to just kind of like almost like a sandbox. You could, you know, with very limited capital, obviously, but you could do almost anything you wanted. You didn't have a ton of bureaucracy you had to go through. So it was just really exciting to like hit the ground running and start to make change and start to make improvements. And it was just really exciting.
I love that. One of the things that you mentioned that stood out to me was you all got along really well. And I think it's maybe an underappreciated skill, just getting along with people. No There's a good friend of mine who used to be a customer, and he's no longer a customer, but he's a good friend of mine. And he was visiting just last week. We're walking around, and he's done well in life. He's done really well. And I said, hey, what do you think it is? Like, what do you attribute this success to that you've realized in life? And he says, well, I think two things. One was that basically since I was a very young adult, in fact, maybe even slightly before he was an adult, he was kind of on his own as far as figuring out how to pay for life. His parents didn't have a lot of money, and so he figured out, you know, he worked 3-4 jobs to put himself through college and things like that. He said that was one of the big things, just learning at a young age how to figure stuff out on your own without having to rely on other people to tell you what to do. But the other thing he said, which I think is equally important, is he's always been really nice to people. and that's come back, you know, to him, full circle, right? And I just think it's such an important thing. In theory, it's really easy to do, just to be nice to people and get along. So anyway, for sure, I think that's a really important point there.
Yeah, we get along great. The owners of the company, and myself, we have to work really, really closely with each other, like, and really have really difficult conversations and call each other out when when we think we're making the wrong decision. And the great thing is the three of us have had the right personalities to be able to accept that, right? And for them to tell me, like, Chris, no, you're going in the wrong direction here. And vice versa. And having the ability to listen and respond to that appropriately, is really, it's one of the hardest things in the world, but it can be so powerful when you pull it off right.
Yeah. Yeah. And I feel like it's easy to say, oh, sure, I listen to people. I take people's feedback and really listen to it. But it's one thing to say that and another thing to actually do it. Like you said, one of the hardest things in the world, because we all have our blinders on, right? That's right. We think what we see is the right way, but yeah. Well, what kind of PCB manufacturing is Worthington really good at? And is there a type that's not so great a fit for your company?
Yeah. So, it's important to keep in mind that we are not a fab. So we're not making the bare circuit board. We're ordering, and we're partnered with the bare circuit boards, and we're doing the assembly, the soldering of all the components on top of the circuit board. And those are kind of two different disciplines. And usually you find most businesses are one or the other, and they partner with each other. There are plenty that do both, and we have hope and a dream that someday we'll be able to do both. We would love to have in-house capability to do our own PCB fab, but we do assembly. So I just wanted to explain that because it's important to know the differences, because that'll set off the rest of these conversations, right?
And the fab part, you're talking about like cutting out the blanks of the board, right?
That's right. Yeah. So that's right. Yeah. The blanks of the board. And it's before you put all the capacitors and resistors and microprocessors and everything on. We like to call ourselves glorified solderers. That's all we do. We just make solder joints. The fab folks, they're buying the raw material, they're chemically etching and drilling holes and plating and doing all that kind of fancy stuff with all those chemicals and everything.
Got it. Yeah. Okay. Yeah.
Sweet spot for us. We've always been really, really good in that 1 piece to 100 piece range. It's kind of a market that the United States continues to have pretty good strength in, because we have a lot of innovation in the United States still. And those innovators need prototypes and they need ways of proving out their ideas. And so the market is quite strong for those needs here. But lately, I'd say, particularly like since the pandemic, I have no idea why. We could theorize all day long, but we've seen more and more demand for an increase in volume. So, going from, we get the occasional 1,000-piece order here and there, 500 pieces. That was very normal. We'd get one of those a week or a couple of those a month, something like that. But now we're seeing them like regularly, like really regularly.
Oh, wow.
And we're seeing customers, they're like, I need 10,000 of these a month. And that's a different challenge for us, but a really exciting one. We don't necessarily know if it's a financially exciting one yet. We don't know if we can be real competitive in it. But from an engineering standpoint, it's really fun because it's totally different challenges, right? Like when you're building like 2 boards, if there's something weird about a part, you'll make it work. You'll sand a little bit here, you'll polish off a little bit there, you'll hand place something rather than use a machine. But then when you have to build 10,000, something that's not quite right becomes like a huge deal. Right.
Yeah.
So the challenges that come with all that kind of volume have been really exciting to tackle, and really the sort of I don't know what it is, that tickles that part of the brain where like you make a small change that has a big improvement and you see that cascade over 10,000 pieces is just like super thrilling to see. So that's been a lot of fun. Something we've been able to challenge ourselves with a lot more lately, and so far, been successful with it. We'll see how it goes long term, but yeah, we're enjoying it. But still, the 1 piece to 100 piece range is still kind of our sweet spot. But we're looking forward to the new challenge.
Super exciting. So we're equipment people here at Pipeline. We love building new custom equipment, which made me wonder what does the equipment look like for fab and pick and place and all that stuff associated with producing PCBs, especially actually not especially, both in the lower, small volume prototype range as well as the higher volume range.
It's some of the coolest equipment I've ever seen in my life. And it's probably part of the reason I'm still in it because I just find it so cool. Like I find machining equipment pretty neat, like your Haas machines and that's the only brand I know, I think, really, because I'm a Formula One fan. It's about the only reason I know what a Haas machine is.
Yeah.
But, those are neat, but like I've always been turned off by like the smelliness of them and the
I love that smell.
It's a great smell, but like I don't think I want to experience it all day long, right? Like I love how like clean and tidy the equipment is that we use. But the pick and place machines that we operate are definitely like kind of the thing that people really think of when it comes to electronics manufacturing, picking components up and placing them onto the circuit board. And it's hence the name of our podcast, Pick Place Podcast, because it's sort of the heartbeat of every manufacturer's operation. Do yourself a favor and just Google pick and place machine and just allow the algorithm to wash over you, man. It is just like watching these machines run is super, super cool because they're so crazy high speed. We bought some new machines recently from a Japanese manufacturer, some of the fastest, most amazing machines in the world. They will place if I have the numbers right, they'll place 55,000 components per hour, and
that's staggering.
It's staggering, and it's so fast. Your eyes cannot keep up with it. Like
my gosh,
even a high speed camera. So I was having an issue with it recently. I was having trouble with anyway, I won't get into the details, but I took my iPhone and I set it to 240 frames per second, and I put a big light on it. And then I recorded it. I'm thinking 240 frames a second. I'll figure out what's going on. No, it just laughed at. It's so much faster than even a high speed camera.
Wow.
It's really, really, it's quite cool. But in a low volume manufacturing operation, and a high volume manufacturing operation, you'll see basically all the same machines. Different manufacturers, but you'll see stencil printers, you'll see pick and place machines, you'll see reflow ovens, selective soldering machines, three-dimensional automated optical inspection machines. You'll see all these same machines, no matter kind of the size of the operation. This is because the technology kind of demands it. You kind of can't build these things without having all of the right equipment. You limit yourself to the kind of tech that you can do. So, for example, like the machines we just purchased are, it's an open secret that they were more or less designed for Apple to build the iPhones and iPads and stuff like that. And then, they sell, many thousands to Apple, but they get to take that design that they engineered for them and sell it to everybody, right?
Yeah.
So we have the capability now to build almost anything, right? The only thing that you might have from, say, a smaller shop, say like us 10 years ago, we just couldn't build the really tiny stuff. It's more of like a capability limitation than anything, but you'll still see a stencil printer, a pick and place machine, a reflow oven. That process is still so proven and solid and reliable. The days of plywood workbenches and soldering irons assembling your circuit boards are kind of a thing of the past because, the components are just so small now, right? If you're building a relatively simple board, you can do that. And trust me, I've done it because I've done design work and it's like, I don't want to tie up this pick and place machine, this $1 million assembly line to build just 2 prototypes here because I've designed it in a way that I can build it. I designed the parts large enough that I can build it myself. But if they were too small, I'd have no choice. We'd have to build it on a machine, so that's what you start to see. I don't know if this is a visual medium or an audio medium, so I'm not sure I could really describe what they look like, but they are cool to watch. I'm not sure what else to say.
I'm going to go Google that or on YouTube and find some videos after this recording.
You have to, yeah.
The components, do they come on reels?
Yeah.
Is that how they're typically supplied? And then the pick and place machine will pick it off the reel and then place it onto the board?
Yeah, the history of this is actually super fascinating. It started out, I don't want to go too much into history because we could spend the next 45 minutes in it, but the surface mount technology, when they were developing the ability to place components on the surface of a circuit board rather than through the board, they needed a way to feed these pick and place machines. And they actually looked to the film industry because the film industry had these tapes and these reels to hold film. And so they adapted that technology to hold components. And so if you've ever seen, kind of the iconic, movie theater projector film can kind of a thing, it doesn't look too dissimilar from that, really.
Interesting.
Okay. Much lower cost. It's not the really fancy, photo film that they use, but yeah, so they come in like a carrier tape, like an embossed carrier tape. And then they have a very thin film of like a Mylar tape that goes over that so they don't fall out. And then those get loaded into what's known as a feeder, which is its own machine in and of itself. These are pretty sophisticated, fancy little tools. They have computers built into them. Well, microcontroller, very simple computers built into them, and all kinds of machinery to advance those tape and to pull off the cover tape, and then those get loaded into some kind of a cart, and then that cart gets loaded into the machine, and then the machine has a head on it that flies around in an XYZ robot, and that head will usually have many, many, many tools for picking the parts. Yeah, not just one.
There's got to be tiny tools. I mean, some of these parts are really small.
Yeah. So the head itself will, like the smallest head itself will hold about a 7 millimeter tool. And that's the tool though. That's the tool going inside the head. The tip of that tool, the tip that is actually making contact with the part, the smallest one that we have is 0.3 millimeters outside diameter. The outside diameter. 3
millimeters. Yeah. Oh my goodness.
and they're machined from some kind of crystal because they're super, super hard. So that they last basically indefinitely, so they don't wear out. Yeah.
And what is the mechanism by which they pick things up? Is it like suction?
Vacuum. Yeah. Yeah. It's
vacuum. Yeah. Mm-hmm. Okay. Wow. Going through a 0.3 millimeter OD tube.
Yes. Incredible. I don't know what the ID is. I didn't measure it. Yeah.
Amazing. All right. I'm going to have to fly out there one of these days and just tour your factory so I can see all this stuff in person. It sounds so cool.
There's a couple videos of our factory on our YouTube channel, but it's been a long time since we took a good one. We want to do more, especially now that we have this new equipment. We really want to show it off and because it's pretty cool. If you do nice. Google, like I recommend searching on YouTube or whatever for pick and place machine, or SMT, use the term SMT, pick and place machine. But the two in particular that are kind of the most visually stunning, are one of the older ones from the 90s was called a CP6, as in Charlie, forget, Panda 6, numeral 6. Those were kind of like in the heyday of SMT in the 90s, like they were the bread and butter. Those machines were absolutely insane, but they were built to just run and run and run and run. You could not, like, if you wanted to run a different job, it's going to take you 8 hours before you can get up and running on a different job. The newest machines are way more modular and way more flexible. And you can change them over in just a few minutes, but they're not quite as visually stunning as the old CP6 machine was.
Okay, cool. Well, what are some of the typical lead times associated with getting a custom PCB? I'm sure it depends if you're getting one or 1,000 or whatever, but generally. Yeah,
so typical. If you've got more money than Apple, then you can afford to get them in 24 hours. We have actually done.
So that's going to be a no for most of us.
Most people. We've done some as quick as 3 days. That is possible. We have a very limited capacity for doing that, and that fills up each day pretty quickly. But the general, what you'd usually expect is like 15 to 20 days if you don't want to spend a fortune. And I'm talking business days, by the way. These are all business days.
Okay.
15 to 20 business days. That's kind of the sweet spot for most people from a cost benefit, perspective. Honestly, even 10 days usually, you can get it done. The thing is, it's all about part availability, and whether or not you can get the parts and what the market is like. And right now it's a complete disaster. So, say assuming all parts are available, those are the numbers. And then from there, it's whatever. It's like, if you can get the parts, as soon as the parts arrive, then maybe, 5 business days or something like that. Once we have all the parts in the building, 5 to 10 business days, once all the parts are in our building. Yeah.
Mm-hmm. Got it. Okay. What are some of the biggest technical challenges in PCB manufacturing?
Size, right? Everything getting so small is really, really quite challenging. It's like, it's not that it's like any more challenging than anything else. It's sort of just you have less room for error. So if you're, say you're an archer and you're trying to hit your target, if you've got a 12-foot target, you're going to hit that thing all day long, right? If you've got a 2-inch target, it's going to be much harder. And making sure that your manufacturer has the right equipment to hit that 2-inch target is going to help them be successful. And that's kind of the most challenging thing we run up against. But honestly, for the most part, like, that's not really what we struggle with. What we struggle with more than anything is part management. It's because you got to understand, like, we're going to build the job on Monday because today's Wednesday and then we have Thanksgiving. And so we're going to build a job on Monday that has 229 unique parts on it.
Give me a sense for where that lies in the range of complexity. Is that medium complexity, high? It doesn't sound like low, but
it's high. Yeah, it's high. Okay, I would say it's on the low end of high complexity because I've heard of some boards that have like over 1,000 uniques, but those are very rare. Those are the 0.001 percentile. I would say of high complexity, your over 200 uniques is your bread and butter. This is a highly complex job. Over anything over 200 uniques. If you've ever seen an Arduino or a Raspberry Pi or something like that. These are kind of like very popular microcontrollers that a lot of people integrate into their projects and stuff. Those are fairly low complexity. Those are probably maybe 30 or 40 unique part numbers. That's very simple, kind of do all day long. We tend to do anywhere from that range up to like 100. Seems like almost all jobs are somewhere in that range up to 100, 120. Over that, it starts to get more complex. And the biggest issue with having all these unique parts is like you have to manage each one. You can't lose them, right? Just job one, don't lose the parts. And these are tiny, right? And so you have these carriers, and it just becomes sort of a logistical, I don't want to use the term nightmare because it's what we do every day. We're not living in a nightmare, but it's a logistical problem that you have to be very disciplined to maintain and make sure you can identify all these parts, that they're the correct parts, they're labeled properly, they're where they belong, so that by the time you load them on the machine, you're putting the right part in the right place. Because most of these parts look absolutely identical. They are visually 100% identical. You cannot differentiate one from the other. But electrically, they're quite different. So then you have to have the right equipment to identify them electrically before you place them on the board. So our machines have electrical verifiers for those sorts of things. But, it's the logistics of managing the complex, the parts. I mean, we have something like, I think we have like over 60,000 unique parts in our database that have, unique parts that have come through our factory over the years. It's, at the end of the day, we say that all we do is make solder joints, but really all we do is manage parts. it's really the hardest
real
problem.
Business.
Yeah. That's it.
Oh, that's a very interesting insight.
Yeah.
I can appreciate that. We just finished a job a little while ago where we had something like 300 unique parts and a little over 700 total parts, and that was just the custom stuff, not the COTS, not the screws and the nuts and things like that. And we ended up having like 8 tables just covered with all of these parts, right? And signs for which parts came from which vendor and things like that. And these are big parts that you can easily look at and say, okay, yeah, this is part number XYZ.
Sure.
This is part number ABC. I can't imagine the complexity that goes on managing that level, that number, like quantity of parts when they're so tiny and not differentiable. Yeah.
It's a headache for sure. And that's why carriers become very important. The carrier that we put them in, the reels, the bags, the trays, these sorts of things, and having those clearly labeled. And then don't get me started on moisture sensitivity. That's a whole, I mentioned earlier, there's ovens involved in the manufacturing process to melt the solder. Well, it's a mass soldering process. In other words, the entire thing is soldered all at once, as opposed to individual solder joints like you would do with hand soldering. And so these moisture sensitive devices, they're hygroscopic basically, or there's materials in them that'll allow them to absorb moisture. And then that moisture gets trapped. And then you put them into an oven, and guess what happens? Pop. Literally, it's called popcorning if you didn't manage your moisture-sensitive devices properly. So you have to, there's a clock that starts ticking as soon as you open that bag. You have to get that thing into a reflow oven before it pops.
Interesting.
Yeah, and so, running against that clock is a lot of fun.
Quote unquote fun.
Yeah. Just think about it. The most stressful situations you've been in life, usually there's a clock involved, right? You're trying to catch a flight. True. It's always, there's a deadline. You've got to get to the airport and you got to get through security, and it's the most anxiety inducing process. And in manufacturing, when there's a clock like that, it can be stressful. And, sometimes that clock is less than 24 hours. And so we have to, you have to get you have to set up 229 feeders, and don't open the moisture sensitive devices till you're ready to run. You know what I mean? Like all these, and then if it's a double-sided board, it means you have to put it through the reflow oven again. The clock is still ticking, even though it's gone through the oven once. It's still ticking. It's still absorbing moisture. You got to get it through again.
Wow.
Yes. So part management. It all comes back to part management.
Appreciate the complexity there. Wow. Yeah. Okay. Well, I'm going to take a real short pause here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Chris Denney today. So, Chris, sometimes I talk with machinists who are making mechanical parts, and they'll lament to me, "Oh, I had to make this part the other day, and I think the designer was just out of school or something because there were sharp internal corners and they're impossible to make, and this and that." I'm sure that analog exists for PCBs as well. What are some of the common mistakes that engineers make when designing PCBs?
Man, I'm going to try to keep this short,
Where do you start?
Where do you start? I mean, really, the biggest thing is just making too many assumptions, right? And it's like, but when you're naive, you don't even know what you're assuming. You know what I mean? When you're starting out, you don't even know what you're assuming yet. So what
are some of the most common
my heart goes out to them.
Rules of thumb.
Just don't use the tiniest parts you find, right? So if you can fit the part on the board, fit the part. Don't try to go using the tiniest, because there's components we use that are 0.2 by 0.1 millimeter, in size, right? It's insanely small, and and those parts are insanely difficult to build, and they're expensive and require special tools, and on and on and on. If you can fit the part, fit the part. So don't try to use tiny parts all the time. The other thing is, we have, this could go down quite a rabbit hole, but there's, we have machines to handle boards. So, a lot of times people, when they're designing circuit boards, they're probably used to ordering them themselves and building some prototypes on their workbench. This is a very common thing. A lot of novice engineers do this. A lot of college students do this. Totally normal process to go through. And hugely valuable. I cannot recommend you do this enough, because you learn so much through this process about your own design and mistakes you've made, the assumptions you've made, and you'll learn on your own without upsetting the Chris Denneys of the world, right? But once you get to the point where you do have to hire a manufacturer for whatever reason, because of the technology or the volume or whatever else, understand that manufacturers are very, very good at what they do, and rely on them for their expertise. And what I'm getting at here is, when you've ordered those circuit boards to hand solder yourself, those are for building on a workbench and hand soldering. Those are not for manufacturing. The circuit boards that you buy from very popular businesses like Osh Park and JLC, and there's there's a huge one I can't think of the name of. Anyway, there's these popular, and they're great. You get like 5 boards for $5. It's insane how you can get these things, right? And that's what we're used to. But those are unusable in a manufacturing operation. They don't have the necessary breakaways. They don't have the necessary visual indicators for the machinery to identify where is this board inside the machine. There's all these features that we need that those don't have. So often, we have to break the news to these poor people, like, hey, I ordered 100 circuit boards. I'm going to send them to you. Can you build them for me? Like, oh, we can't use those. Like, we can't use those. Literally, it will be cheaper for us to buy brand new circuit boards than it will be for us to try to manage those boards that you've already ordered. So that's a common mistake we see a lot of times. People trying to send us, and I'm talking about the bare, remember we talked about the bare circuit board first before we soldered all the components on it. So yeah, making that assumption can be difficult. I wrote down a couple other things. I just want to touch on them. Oh, that's what it was. So we actually, there's actually an entire episode of our podcast kind of dedicated to this topic.
Okay.
About, small decisions that you make in your design process that have a big impact in manufacturing. I looked it up before we started recording. Episode 29 of our show is a good reference. And it's all about kind of like the big heavy hitters that really are quite challenging about things. But I guess at the end of the day, we always sort of a catchphrase for our show is, make it bigger and have a conversation. So
that's great. Great.
If you're interested in hiring a manufacturer, I don't care if you're CNCing a part, laser cutting, whatever, right? Assembling a circuit board. Call the manufacturer before you're really ready to hire the manufacturer. And ask them some of these questions, and you'll save yourself a lot of time. I know conversations can be annoying and nobody wants to pick up the phone. We're engineers. We tend to be introverts. We tend not to want to do this. I get it. But trust me, you're going to love it. Like if you get the right person on the phone, it's going to be hugely valuable for you and you're going to learn so much from it. So make it bigger and have a conversation.
That's a great place to start. Make it bigger and have a conversation. Yeah. Very good. All right. Well, what are some of the industry standard software packages for PCB design?
Yeah. So a great one that a lot of people use, and it's sort of a reasonable price for what you get for it, is a software package from a company called Altium, or maybe Altium is the product now and it's a different company. I forget, but that's a super popular one. That's one we see from designers all the time. Altium, Altium. And, but if you're, kind of new and you don't want to spend, cause it's thousands of dollars, it's not cheap, right? You're going to spend thousands of dollars on it. Another very good one is an open source one called KiCad or KiCad, depending on, what war you want to get involved in. Cause everybody argues about whether or not it's pronounced KiCad or KiCad. It's a great tool. Yeah, it's a great tool, open source, and so it's free. Anybody can download it, and they can, if they're coders, they can write to it and submit changes to it. Another really popular one is owned by Autodesk called Eagle, which is now being blended into Fusion 360, I think. And I'm not keeping up with it entirely. But Autodesk has really taken that one and done a nice job with it. And we see a lot of designs from that. Probably the biggest one in the world though is Cadence. But Cadence is like tens of thousands of dollars. This is what Apple is using to design the iPhone. This is what Raytheon is using. That's the Rolls Royce. Yeah. This is the big one, but yeah, for the most part, smaller businesses, they're all, if they're a business, they're probably using Altium. If they're an individual, they're probably using KiCad or maybe Autodesk Eagle, Fusion 360, that kind of thing. Yeah.
Great. Okay. So some terms I hear in the PCB industry sometimes are PCB design and board layout. Are those completely separate terms performed by separate people, or is that kind of saying the same thing in different ways?
I guess it depends on how you define design, right? Like I always consider like the design of a product is more than how it looks. It's how it works, in my opinion, right? A well-designed product functions really well. That's my opinion when it comes to design. I think aesthetics is different. I think a lot of people confuse aesthetics and design as two different disciplines. What I consider PCB design and is something a bit more than PCB layout. I think they can be used interchangeably. Personally, I think it's perfectly acceptable to use them interchangeably. But I think of design, we have all these conversations about design for X, design for manufacturability, design for test, design for. So design can really come before layout. Like in the sense of having a conversation about, hey, we expect to build 10,000 of these. So we need to design for manufacturability, right? Hey, we need just to prove out whether or not this chip works. We just need 5 of them. We need to, design for this chip, make sure that this other things kind of take a back seat to it, right? Hey, this needs to be super reliable. So we design it for test, and we need to be able to test these really reliably and know that they're going to work and that kind of thing, and know that they're going to work in negative 50 degrees and that kind of stuff. So, but yes, I think for the most part, I think you're right. I think most, like colloquially, so to speak, I think design and layout tend to be kind of used interchangeably. Yeah.
Okay. And how about the overall, I'm not exactly sure how to say this, like the architecture maybe? I mean, we need this board to perform a certain function, and to do that, we need these different components, and they have to be connected in such a such way. What is that effort referred to as?
Yeah. So that's,
the design?
I guess I would say that's design, right? So, cause that would be
Okay.
at like the schematic level. So now, think of a circuit board as nothing but like a really fancy wiring harness. Really, at the end of the day, that's all it really is. A really fancy wiring harness,
That's
and
a
you've
good way
just
to think of it.
soldered all these things together rather than crimped them all together.
Yeah.
And so when you're saying like, oh, we need this much memory and we need to be able to control this power and generate this waveform and, send this signal and receive that signal, that would be more PCB design in the sense of like, what is this? What is the job to be done with this circuit board? And then the layout comes after the fact. But the thing is, what we're trying to accomplish with circuit boards nowadays is becoming so complex that the design and the layout are informing each other. We recently had an episode on our podcast all about impedance control. And basically what that means is now the circuit board is more than just a wiring harness. It now is becoming a component in and of itself. The actual copper traces of that circuit board are performing a function for the product.
Wow. And
you need to make sure that when you're doing your design, you are considering the fact that you need to control the impedance. This is just one example. So that's going to have a limitation on what that looks like mechanically and how that's going to fit into your enclosure. Excuse me. We talk about fixtures all day at work, fixing things together so we can build them. So that's what's in my mind. The enclosure, right? So now your enclosure has to take into consideration, we need a trace length of this and this width. And, we can't, if we're going to put an antenna here on the circuit board, then we need to understand that antenna has to fit in the enclosure in a certain way. And so all of a sudden design and layout are really informing each other. And the layout person goes back to the design people and says, hey, I can't make this work. What you're asking me, it won't fit. Like, we can't do this. And, I've seen some really interesting things. Like, I love looking at iPhone teardowns and stuff like that because you see sometimes, like, I'll never forget seeing, a capacitor. Now, capacitors generally look like a brick, like you're building a wall, right? They're just shaped like a brick. They're rectangular, a little bit of meat on them, right? They're a little tall. They're not super thin. They look like a brick. And they're always rectangular. Always rectangular. And then there was this one that was like L-shaped on an iPhone. And I'm like, you gotta be kidding me. Apple has such strength and such volume that they convinced some capacitor manufacturer, in order to get this to fit, we need you to make this capacitor L-shaped. And
fascinating.
So I would love to know what conversation took place in the room where they decided they had to get a specially made L-shaped capacitor for their design.
They needed that 20 thousandths of an inch of space.
Literally. Yes, exactly.
How fascinating. Well, we don't do any circuit design here at Pipeline. Most of what we do is mechanical, and we do, some programming and controls and things like that, but we don't do any actual like PCB design or circuit design. But we have worked with some customers who, they already had the circuit design, the schematic, and they just needed to document that in a way. And it was like the blind leading the blind, honestly, when we were trying to figure out like, how do we document this? And so what we ended up doing was just, doing a mechanical drawing of this. We had overall dimensions of the PCB, and and then in the notes, we referenced, see such and such Gerber file package for, all of the electrical documentation. And we just left it at that. And it seemed to work. We got the parts and, and they worked. But is there what's the typical way of documenting, PCB designs? Is it just the Gerber files, or is there anything like mechanical 2D drawings that come along with it?
So, I think I have to ask you a couple questions just so I can answer this properly, if that's okay.
Please.
Your circuit board, you don't have to get into specifics of what the product was or anything, but was it were you designing an enclosure or you were designing a machine, or like what were you doing for them that there was a circuit board involved?
It was a connector, and the connector got plugged into a generator, and the circuit was embedded within the connector and communicated with the generator.
Okay. All right. That makes sense. So Yeah, gotcha. So basically you're putting a circuit board into an enclosure at the end of the day. And so you're designing this connector, you're designing this enclosure for them. And, and it's got copper and terminals and stuff. Anyway, so they did the design of the circuit board. Your customer designed the circuit board?
Yeah, it was even once removed. They had a subcontractor.
They hired,
yes, done it.
Very normal. That's very normal. Okay. I understand now. So when we end up in this situation sometimes, but it's rare. Usually we're in the situation where we're working with the people who actually designed the board originally. But occasionally we do get somebody that comes to us that says, we're the finished goods manufacturer, whatever you want to call it. They're getting the CNCing done, they're getting the injection molding done, and they're sourcing all these materials together, and they're doing the final assembly. And we're one piece of that supply chain. We're the manufacturer of the circuit board. That is actually somewhat of a tricky situation for somebody such as myself to be involved in, because oftentimes these devices are so complex that there will be questions. And Aaron cannot answer that question. He's the mechanical engineer. He has no idea whether or not I can substitute an X7R temperature coefficient capacitor for an X5R temperature coefficient capacitor, right? Because we can't find the X7R.
You are correct, sir. Yes.
So it becomes a very complex situation. The way that you would document that in your case is exactly what you've done. Basically, give us a zip folder with everything that your customer has given you, and we can probably take it from there. Likely, and it sounds like they hired a design firm to do this work. Most design firms worth their salt know how to document things in such a way that say, hey, if you can't source an X5R, X7R is acceptable here. Here's the tolerance we'll accept for this design. This particular component needs 0.1% tolerance, but these components can be 5% tolerance. And if you get a 1%, that's fine. Like, use a 1%, no big deal, right? Because it's within the range of the 5% tolerance. So usually the most questions we run into are easily answered within that documentation package. But it still is tricky, because what'll happen is, let's say the supply chain breaks down. Not that that's ever happened. It's not like there's ever been a semiconductor shortage. And we run into a situation where it's like, well, nothing available on the market will work here. Nothing. We're stuck. We cannot proceed with this build. We need a connection back to the designer somehow, to go through this chain, and somebody needs to be able to say, like, yes, you can use this kind of a part or substitute this kind of a part. This can become really tricky with semiconductors, right? Things like capacitors and resistors are quite simple to find alternatives to, but semiconductors, really, really tricky, because we don't know the application. We don't know what they're being used for. We could be making concrete life jackets for all we know. Like, we're just building to print, so to speak. So you've done the right thing. You've given us everything that we possibly need. I think the one thing we always wish we had in that documentation package is a contact person to reference for technical questions.
Got it. Okay.
Email is the best tool for this. And the reason email is the best tool for this is because part numbers can have like 30 characters in them. And having the exact, Control C, Control V is super important to get right. Because if you type one character wrong, you've bought the wrong part. So email becomes very important. A lot of times when we have a conversation like we talked about earlier, it's followed up with, okay, thanks so much for the conversation, guys. I'm going to follow up with an email describing everything we've talked about, and I need everybody to tell me that they approve, these decisions in that email. Some kind of a paper trail, because it becomes really difficult. It's not just buying an M3, flathead. It's it's pretty complex.
Okay. All right. Cool. Well, maybe just one or two more questions, and then we'll wrap things up here.
Sure.
How has the industry changed over the past few years as the supply chain issues have become challenges, and what do you expect to see over the next few years?
So for us, it's had a big impact. We used to be able to buy and build almost everything we needed. Customer would come to us with a design. We could buy all the material and build it. Now we're getting much more into a supply chain management role, which we're not really used to, in the sense of like now we have to kind of like, we have to hold literally tens of thousands, sometimes hundreds of thousands of dollars worth of material for our customers and keep them safe and secure and dry and yada, yada, yada. So we're having to invest in technology we never even thought we'd have to invest in before, we just thought we would just continue to invest in production tools. Now all of a sudden we're having to invest in management tools, material management tools, which is kind of not brand new for us, but it's just a whole different level of material management. We always manage material, but this is on another scale. And now we need technology to help us with this scale. That's been very new for us and something we're getting better at. And again, like everything else, exciting new challenges. What do I see on the horizon? Gosh, I'm terrible at speculating about these things. Who thought this massive supply chain crisis would be an issue? The level of innovation I don't think is going to slow down anytime soon. I think there's still going to be a demand for, prototypes and new products and things like that. I do think in the geopolitical system that there is more hesitation from a lot of businesses to immediately go overseas for manufacturing. Don't get me wrong, overseas manufacturers are amazing. Just take a look at an iPhone. It's absolutely amazing what they're able to do. I have no objections to their ability to deliver a quality product. But a manufacturer overseas they have the same issues that everybody else. They have no control over the geopolitical system and whether or not they can continue to be competitive, right? And whether or not people's feelings, because feelings matter, tell them, I'm nervous about getting my products made outside of the country that I live in. So I'm gonna hire a manufacturer here in the United States if I can afford it. Because at the end of the day, it's manufacturing in the United States is not inexpensive. You have to pay for healthcare and all these kinds of things. But we have continued to see growth from businesses that would otherwise usually have been using lower cost manufacturing services. And whether or not that trend will continue, I have no idea. You never know. New leadership in one country after another. It's just, one country invades another. You have no clue how these things are going to go. But that trend is taking place at the moment. I don't know how much longer it'll go on for. Selfishly, I would love for it to go on longer because that means I can continue to do what I love.
Sure. Yeah. All right. Well, last question here. You're partnered with a company called Circuit Hub.
That's right.
What can you tell us about them and how they help engineering and manufacturing teams?
So actually the Pick Place podcast is a partnership with Circuit Hub as well. And Circuit Hub came to us about 7 years ago. They were a startup at the time and they were developing software to make manufacturing circuit boards easier. More on the manufacturing side than on the design side, which was a totally different approach that a lot of people weren't really focused on for a long time. And what they have developed is computers that can generate a quote, which is, sounds simple and naive and obvious. Like, Proto Labs has done this for a decade now or 15 years, right? But they looked at what Proto Labs did and said, we need to be able to do that for circuit boards. And the cool thing about Proto Labs is they can just buy aluminum and steel and plastic and make it work. We have to buy 60,000 unique part numbers. It's really challenging to make that work, right? So, we've learned over time that, that is a whole new ball game that we're trying to get good at, and Circuit Hub is helping us with that. And the partnership developed because they didn't have their own manufacturing capacity. And they needed a partner that could actually do the work, and so that's what we've been. Now, Circuit Hub, they do not deny the fact that they also have their own factory. So Circuit Hub has its own circuit board assembly factory, but they still hire Worthington Assembly. Now, the cool thing is both factories are in the exact same building. I work in both of them every single day. And
funny.
Yeah, but they complement each other. So what Circuit Hub's factory has remained hyper focused on is super short lead times of low volume products. Think like 1 to 10 pieces. And they're kind of untouchable. They're what they've been able to achieve, and they've structured their business around that. And they've pushed aside anything over that. Where they pushed it aside was into us. And so we've gotten better at the higher volume stuff. So it's been a great partnership where you can get an instant price on your product. And I don't mean this hyperbolically at all. It is an instant price. It is a real market value price. You enter a credit card and you pay and you get a circuit board. It is not it's going to be $15 and then turns out it's something different. Right. And, and I've been doing this a long time. Like I said, since I was in high school. I truly, truly believe in my heart of hearts that it's one of the most innovative things to happen to circuit board manufacturing in a decade, or more. And, I don't know how it worked out that I got to be involved in it. I'm thankful that I'm on this side of it and not competing with it, because I really think it's going to be a game changer. And, it has been for many customers who've been able to use it so far. I'll leave it at that, but as if I couldn't go on longer about it.
Well, I'll include a link to Worthington, of course, but also Circuit Hubs in the show notes.
I appreciate
here.
that.
Great. Well, Chris, this has been a delight. Thank you so much for spending some time with me today. How can people get a hold of you?
A very simple way, if you're on Twitter, you can reach out to me at W Assembly, all one word, W Assembly. But email me. It's CDenney, CDENNEY. Don't forget the second E. Everybody forgets the second E. They all forget the second E. CDE.
Not Denny's the restaurant.
No, that's correct. At worthingtonassembly.com. I am a prolific emailer. If you email me, I almost guarantee you I will respond. It may not be in a day, but you will almost certainly get a response from me. And, of course, more than anything, please subscribe and listen to the Pick Place podcast. If you do any circuit board design, I think there's a lot of gems in there for you. The whole concept behind the show is helping peel back the curtain behind, electronics manufacturing. What is going on? What are we actually doing? And how does that inform your design? And we've had some great guests and some awesome topics, and we get into some nerdy stuff, dude. Like really, what is solder? Like, what is it? Like, what's the alloy and why is it the alloy? Who decided that SAC 305 was the appropriate alloy for SMT, and what are the characteristics of that alloy and why is it used? Like, it's some truly nerdy stuff, but that
is truly nerdy, and I love it.
So I think this is a fairly nerdy podcast, and if anybody's into circuit boards and ordering them, I think they would like the Pick Place podcast, and you'll hear all my contact information at the end of that show too.
Awesome. Wonderful. Well, Chris, thank you so much again for joining me. Anything else that we should go over?
No, I think I've gabbed on long enough. I appreciate your time, Aaron.
All right. Thanks so much, Chris. I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.